y'all do it. The derivative of sine x times the derivative of what? Cosine x. That was the bottom, right?
Mm-hmm.
And then minus cosine x times the derivative of sine x all over sine x quantity squared. Yes, no, class? Yes, no? And what's the derivative of cosine x? What's the derivative of cosine x?
Negative sine x.
And then minus cosine x. What's the derivative of sine x?
Cosine x.
All over sine squared x. And that became negative sine squared x minus cosine squared x. Yes, no? But please know you have a common factor of negative what? 1? So that would be negative of sine squared x plus cosine what? Squared x. All over well, what's that equal to in that case, Miss Lindsay?
1.
And that's when you end up with negative 1 all over sine squared x. And that's how we get the answer to equal to how much, class? So what my class know now, do we not, class? We know that the derivative of, what's the derivative of sine x?
Cosine x.
What's the derivative of cosine x? What's the derivative of tangent x?
Cosine. Is sine x over? No.
Why is it negative secant squared x?
Because it's cosine. Yes, I
We
know.
just derived this. Sine over cosine is actually what, class? So therefore we know the derivative of tangent x is secant squared x. And the derivative of cotangent x, we just derived this, didn't we, class? But what's cosine over sine? So this is negative, this should have been positive, negative cosecant squared x. See how we just derived those two more formulas we got, class? Now these other two we're not going to derive. I'll tell you what I do. I'm just going to give them to you. How's that? And so in that class, we know the derivative of secant x is just secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x. So now we can take the derivative of all 6 trig functions. We can take the derivative of all 6 trig functions. We can take the derivative of all 6 trig functions. We got them all written down, Miss Davis? We have all 6 trig functions written down, do we not? What time is it now? 12:49. So therefore, now in the next test, we can make it really easy. I could have stuff like, where we stop at, number which one? 9?
Mm-hmm.
We could have f of x equals x secant x. See how easy that is? What rule will we use on this?
Product.
Why?
Because it's multiplying.
We just multiplying. And now the product rule says first times the derivative of second plus the second times the derivative of what? First. So that means that f prime of x is, what's the first?
X.
So that's x times the derivative of
Secant X.
secant x. And then secant x times the derivative of,
X.
now I can't make the problem much easier than this on the test. We good? So that's x times, and what's the derivative of secant x?
Tangent. No.
So that's secant x tangent x.
Oh.
The derivative of secant x is secant x tangent x. And then plus secant x, and what's the derivative of x?
1.
The derivative of x is just 1. So our final answer will be x secant x tangent x plus secant x. We good? Now let's pose number 10 says f of x equals, let's do this one, that doesn't really matter. Secant x all over cosecant x. I want to take the derivative. What rule we gonna use here?
Quotient.
What? What rule we gonna use?
Quotient.
We're gonna use the quotient rule. What the quotient rule say?
Bottom. Bottom. Top prime minus top bottom prime over bottom squared.
This right here, class.
Can you keep the number to 10 too?
Huh?
10, you were like,
Hmm?
10, you were 11. Some of the number.
That's a 0. It just looks real small. It's just close together.
I'm gonna say that on my next test. That was supposed to be it. Yes.
You can do that, but it's still my interpretation when it comes to it. I'll tell you what, if you write it like that way and you can prove to me it's a 10 out of 11, we good. We good? So in this case, what's the bottom? That's cosecant x times the derivative of,
No. Yeah, secant. Secant X.
and then minus
Secant X.
times the derivative of,
Cosecant X.
all over,
Cosecant X. Squared.
doesn't really matter what it is, we good, class? And all you need to know is the derivatives. So we have cosecant x, what's the derivative of secant x?
Secant X, tangent X.
And then minus secant x, what's the derivative of cosecant x?
Negative cosecant x
The derivative
cotangent.
cosecant x.
Negative cosecant x cotangent x.
All over. So y'all notice on the top, we have, I don't know, which order y'all wanna put these in? Does it really matter? Cosecant x, secant x, tangent x, and these two negative signs will force this to go to what class?
Positive.
Plus secant x, cosecant x, cotangent x, all over anything common?
The secant x.
What's common?
Actually, nothing.
Any common thing common in both of them?
I don't know.
That's
Secant
all?
and cosecant x.
So my class realize now, they tell me I can factor out secant x, cosecant x. If I factor out the secant x and the cosecant x, what am I left with?
Tangent x and cotangent.
So that's tangent x plus what?
Cotangent.
What can I do then?
Get rid of the, or cancel the cosecant x from the top and
So
bottom.
she said I can cancel one of these. So now she says we have f prime of x is secant x times tangent x plus cotangent x all over cosecant x. Now class, for the fun of it, could y'all write everything in sine and cosine for me here? Could y'all write everything in terms of sine and cosine for me, yes, no? What's another way I can write? Can I write secant as 1 over what? Cosine? Yes, no?
Yeah.
How can I write tangent?
Sine over cosine.
How can I write cotangent?
Negative. Oh, okay, never mind.
How can I write cosecant?
Negative cosecant x
How can I write cosecant?
the cosine sine over. Oh,
Remember the reciprocals? The sine, cosecant? The secant and the what? Cotangent? So if I have secant, that's 1 over what? Cosine. We good? Okay, class. When you divide by a fraction, what do you end up doing? Third grade. 1 over sine x, what I gotta do?
flip it.
And what will I get?
Sine x over 1.
So now y'all understand why I'm gonna get f prime of x. So that could be 1 over cosine x. And y'all also have to multiply this by what? Sine x. And that could be sine x, cosine x. Yes, no? I don't know. We just playing with trig right now, class. Do y'all understand why that's sine x all over what? Cosine x times sine x over what? Cosine x, and then plus cosine x over what? Sine x. Yes, no, class? When I flip this, y'all know that you went to sine over what? Cosine? Yes, no? Can y'all simplify this some more? If I use the Schroeder property, yes, no, class? Anybody know what I'll get?
What is it? Sine x over cosine x squared plus
So she
sine
says-
x cosine x. Wait.
Could that be
Sine
sine
x
squared x
cosine
over
x
what?
times.
Sine squared x over cosine squared x?
Mhm.
When I multiply here, what will I get?
Sine squared x over cosine squared. Wait, what are you doing? Oh,
Plus?
sine x times cosine x, so cosine x.
Well,
Somebody told me 1. Do you understand why you get 1? Yes or no? When I distribute this through class, what happened to the sine axis? What happened to cosine axis? We just get 1. What's sine squared x over cosine squared x? Y'all know that's tangent squared x. So this is actually just now, if my class knew that trick, y'all know that was like being 1 all over cosine x and 1 over what? Sine x. Yes, no? And if you flip this, what do you get? All you did was took the derivative of tangent x, which is what, class? Secant squared x.
okay, so if you fix this on a test, and I do it like that at the top and take the derivative of tangent.
You get it correct. You get it? How much time I got left, Anastasis?